So this video should be very easy for you and very quick because we just finished the foundations of functions and we learned about transforming functions. Now we're going to begin transforming actual algebraic functions, and the first one we're going to learn about is the quadratic function. We know that the parent of the quadratic is y equals x squared. The parent of everything algebraic in transformational functions is always going to have this set of input values. All I do is take these input values and plug them into here. So negative 2 squared is going to give me an output value of 4. And on this particular test, there will be portions of it that are non-calculator. So yes, you will have to know the different parent tables. So let's graph this. And we talked about this the day that we filled out our characteristic sheet. The parent function has a domain of negative infinity to positive infinity. It has range from the bottom of 0 to the top, which is positive infinity. It has solutions of 0. The only solution is where it crosses the x-axis, and that would be right there. It has something called a minimum. Vertexes have two names. It's either the bottom of the parabola or it's going to be the top of the parabola. This one is a minimum. So the minimum here is 0, 0. I can refer to that as the minimum, or I can also refer to it as the vertex. They all also have either a minimum or a maximum value. Since this is a minimum, this guy has a minimum value. The minimum value, if I could spell, is the y of the vertex. So the minimum value here is 0. So what would happen if we did something like this, where we changed our parent function to y equals 2 times the quantity of x plus 1 quantity squared minus 3. And the biggest confusion here is this squared. Everyone now wants to square these. Remember, the squared is the parent function. This is my parent function. I've already taken into account the squared over here with my output. I've squared this. I've squared this. All I really have to do is that transformation, and that transformation. So let's start with the A and the D. Okay, remember I have to go alphabetical, so I do exactly what it says on the outside to do to my y's. So I'm going to multiply by 2, and I'm going to subtract 3. To the x's, I do the opposite. So I'm going to do the opposite of this to all my x's. And now I'm going to plot my new transformed inputs and my new transformed outputs and see what I get. I have a new domain. Not really new. I do have a new range. I now go from bottom, which is -3, to infinity. My solutions are somewhere in between -2 and -3 and 0 and 1. And I'm going to show you on the calculator how to get that exactly. And we're going to learn 3 ways to solve quadratics in a couple days. The one I want you to make sure that you understand is this minimum. So my minimum is 1, -3. And therefore my minimum value is -3, because remember, my minimum value is whatever that is. Let's talk about the transformations really quickly. You're going to be able to do that as well for this unit. My transformations, this guy right here, A is 2, he has a vertical stretch by a factor of 2. This is C. This is a horizontal shift to the left 1. This is D. This is a vertical shift down 3. Now, I do want you to understand that this A, B, C, D, for some reason math decides that they now want to call it A, B, H, K. So a lot of times the vertex is referred to as HK. So this is my vertex. This is referred to as HK. So this would be my H and this would be my K. Notice my vertex is -1, 3, right here, -1, 3, which would be -1, 3, and here again, opposite of this, -1, -3. Sorry, my vertex is -1, -3. I think that's it.